Welcome to part 3 and the final part. In the previous video, we have obtained that our integral secant x dx is just equal to ln tangent of pi by 4 plus x by 2 plus c. And we also know that if we have tangent pi by x plus 2, then we can write as ln tangent pi by 4 plus x by 2 can be written as ln of sine pi by 4 plus x by 2 divided by cosine of pi by 4 plus x by 2, like that, right? From the Euler's formula, we have e raised to I theta is just equal to cosine theta plus I of sine theta. Therefore, to express cosine theta in terms of e raised to I theta, we know that cosine theta is just equal to e raised to I theta plus e raised to minus of I theta divided by 2, okay? And we also know that sine theta is just equal to I times e raised to minus of I theta minus e raised to I theta divided by 2, like that, okay? And this is by using the elimination method. You can try using it. And we know that e raised to negative I theta is just equals to cosine theta minus I of sine theta. Just you put minus of theta here, and cosine being the even function, it will remain as positive only, but sine being odd function, it is minus of sine theta. Therefore our sign get flipped and it changed, okay? Here our angle input is x by 2 plus pi by 4, right? Therefore it's simple as this. Here we can say, therefore from this we can say that the sine theta can be just written as like this. Therefore we can say I by 2 times of e raised to negative I. This theta is this one, right? So input, so pi by 4 plus x by 2 minus e raised to positive I pi by 4 plus x by 2, like that, okay? Divided by, we also have 1 by 2 here, this cosine, and we say e raised to I pi by 4 plus x by 2 plus e raised to minus of I pi by 4 plus x by 2, like that, plus c, right? And if you see very carefully here, you know that this half and this half will get cancelled, and we will have ln of this I, right? I times then this. And from the logarithmic property, we have that if we have ln of a times of b, then we can write ln of a plus ln of b, right? Therefore we can write this as just ln of ln natural log of I here plus ln of these values, okay? So we will have to rewrite this. Now our final job is to figure out what is the value for the ln I. Now to figure out the value, we know that from the complex number, that if we have complex numbers such as z equals to a plus bi, right? This is real part and complex part. Then we know that from the argon plane or the complex plane, that this is the real value and complex value, and this is r, and we have some point here p, and this point coordinate is just r theta, and this is the angle between the x-axis, which is the real value, and the r, and this is just a, like this, and this y value is the imaginary axis. Therefore it is b, like that. Therefore for this value we can also say that z value in terms of polar coordinate, we have r cosine theta plus I of sine theta, okay? And from here what it says is that if we say that ln I value is something like y, then it implies that e raised to y equals to I. That means we have to find the value of the exponent here. Therefore if you see very carefully here, then this can be, our complex number can be expressed as z equals to r of e raised to I theta, because of this Euler's formula, right? Therefore, if we say that our complex value, this one z, right, this one have to be equals to I, okay, then this z value here, this value, the cosine value should be 0, sine theta value should be 1, and this r should be also 1, right? If this is the case, then our z will just be equals to I, right? See our this 0 and sine 1 means I, right? Therefore the z value here is just equals to e raised to y here, and this is only possible when this theta value is pi by 2. This is because sine pi by 2 is just equals to 1 and cosine pi by 2 is just equals to 0, which means here I means our r value is 1 and the angle left, which is this theta value, is just equals to pi by 2. That is the main thing. Therefore our z value is equals to I if it is like 1 times cosine of pi by 2 plus I sine of pi by 2, and it will be just equals to e raised to I pi by 2 here, like that. Now if you observe very carefully here, then if you take the natural log of this, then you will get that this one will be just equal to ln of I equals to I of pi by 2, okay? But if you observe very carefully, this is only our first answer, which is the root answer or principal value. In the initial condition, we have said that this ln I is equal to this condition when our cosine theta equals to 0 and our sine theta equals to 1, which means that we have to find two conditions simultaneously, okay? Therefore, I have here our sine and cosine graph. This blue line denotes the sine graph, which is y equals to sine theta, which I have plotted this theta in terms of radians, and our domain, which is plus or minus 1 for both of the cosine, and this blue line represents the cosine line. Now we have said that our cosine theta should be 0 and our sine theta should be equals to 1. Therefore, if you look very carefully here, you can only see this condition where pi by 2, okay, theta equals to pi by 2, where sine pi by 2 is 1 and cosine pi by 2 is 0. And if you observe very carefully here also, you can see one condition when sine is 5 pi by 2. Therefore, if you see very carefully, this cycle repeats after 2 pi cycle, okay? This cycle is pi by 2, this cycle is pi by 2, this cycle is pi by 2, and this cycle is pi by 2. Therefore, after 1 pi by 2, you will get one condition, and after this, after 2 pi by 2 from this pi by 2, you will get another condition. Therefore, in order to fulfill this condition, our angle value should be pi by 2 plus 2 pi m, okay, where m equals to 0, 1, 2, 3, 4, like that. If you use this condition, then we will get the expression for the ln I. Therefore, ln I in terms of Euler's formula or the value is just I of pi by 2 plus 2 pi m, okay? Now we will get multiple values. For each value of m equals to 0, 1, 2, 3, there will be many answers. Therefore, we will get this and plus ln of. Therefore, our final value is now I pi by 2 plus 2 pi by m, okay, plus ln of this one whole plus c, where m equals to 0, 1, 2, 3, like that. Okay, I hope you all would have enjoyed this video, and I'll see you next video when I derive yet another interesting results for integration of cosine x dx. Okay. Thank you for supporting and watching. Bye.